Hi everyone, let's get started. I'm reading out the question for you. A pendulum is suspended inside a trolley. This is the trolley, this is the pendulum. Find the angle deflected by pendulum from vertical, this angle. If trolley attain acceleration A0 very slowly, A0 very slowly. And the second condition is trolley suddenly attains acceleration A0. So for these two conditions, we have to find out the angle theta. Angle theta will be what? So let us focus on first condition. When the trolley start moving in this direction with A naught, but not immediately, it has gone to A naught very slowly. It means all the time the force acting on the bob of the pendulum, will be in equilibrium. So when it attains an acceleration A naught, at that time also the total force on it when observed from the trolley frame will be zero. So which all forces are acting on it, on the bob? So when you are looking it from inside the trolley, like this boy is looking into this. So one force is this tension force in the thread. The other force is gravitational force. And since the bob is getting observed from the trolley, so pseudo force. Mass of the bob is m, so this will be m a naught, so yeah, pseudo force. This will be your mg. This will be your tension force. If this angle is theta, so this will also be theta. So you can divide the component of T into the vertical component as well as in the horizontal component. And since you are looking it from inside the trolley, so the bob will look stationary. Bob will be stationary from that frame. So let us write the equation in the horizontal direction. So in the horizontal direction, which component of horizontal direction? The component of tension force will be T sine theta, and the pseudo force m a naught. This will be zero in equilibrium, no motion. When you are observing it from the frame, like the boy is observing it. So your T sine theta will be m a naught. This is your equation 1. Second, in the vertical direction, if you take the component of force in the vertical direction for T will be T cos theta. Downward direction, mg. This will be 0. So T cos theta will be mg. This is your second equation. So if you divide equation 1 by 2, the t will be eliminated and it will become tan theta sine theta by cos theta. Tan theta, will cancel out, a naught by g. So theta will be tan inverse a naught by g. So this will be your answer for condition 1. Now let's jump on the second condition. When the trolley suddenly attains the acceleration a naught. So in this condition, what will happen? The bob will shift to a location and the total force acting on it at that time when it is getting absorbed from the frame of the trolley, that is the boy is observing it, will not, the net force will not be 0. So means pendulum will not be in equilibrium state. So let us say that when the jerk was given and it immediately attained an acceleration a naught, the shift of bob in the horizontal direction is this much, and say it as x. For the convenience, we should define the axis. This is your x-axis, this is your y-axis. So this displacement is x. And how much it lifted up, that distance we can say it is y. Which forces are acting on it in this state? Tension force, gravitational force, pseudo force. Because you are observing from the trolley. If we say the length of the cord is L with which the bob is attached, so how much will be this distance? This will be L cos theta. And what was the total length of the cord? We have taken it as L. So y, we can easily see that it is y is L minus L cos theta. And x will be your L sin theta. From this triangle. all the forces which is acting over here is conservative force. So we should think of the work done by pseudo force plus work done by gravity force plus work done by tension force on the bob will be change in the kinetic energy of the bob. So what will be the W pseudo? The force is MA naught and the displacement is in the direction of force MA naught x. What about the gravity? Gravitational force is acting downward, but the lift is upward. So this will be this. And what about the tension force? So tension force, you can notice tension force is acting in this direction where the displacement is happening perpendicular to it. So tension force will not do any work on it because you know that T dot displacement and the angle between that. So cos 90 will be 0. So tension force. So work done by the tension force will be 0. Now the kinetic energy. We are speaking about the instant because immediate jerk has been given and it has attained an acceleration a naught. So at that time, the velocity at this location of the bob will be 0. So change in kinetic energy will be 0 because initial was 0, final is 0. So now we can handle this equation. MA naught x is equal to L sine theta. This will become minus mg L into 1 minus cos theta is equal to 0. So your A naught sine theta will be equal to g into 1 minus cos theta because m and L will cancel out. So we are interested in knowing the angle of deflection, that is theta. So we will convert this into 2 sine theta by 2 into cos theta by 2. G into 2 sine squared theta by 2 by trigonometry. 1 sine theta by 2 will cancel out. 2 will cancel out. So you will be getting tan theta by 2 is equal to A naught by G. Therefore, theta by 2 is equal to tan inverse A naught by G. Theta will be 2 tan inverse A naught by G. This will be your answer for the second question. So what will happen? So these two are your answer. That is fine. But what will happen if the trolley still continues with A naught acceleration? So what will happen to the bob motion? So let us study that. In this condition, the bob was not in equilibrium. Which forces were working on it? Let us draw the diagram over here. This is T. This is mg. Pseudo force ma naught. Angle was theta. T mg ma naught. So in this condition, because the bob has gone beyond, you can see that angle is more than the previous one. So the bob has gone beyond the equilibrium position. So what does this mean? The component of force T in the vertical direction will be lesser because theta increases, cos theta will decrease. So this will be less and mg will be greater than it. So mg will pull it down. It will start pulling it down. So means bob has to return back. Bob has to return back from here. It will reach to its equilibrium position. But due to motion, by this time it reaches here, it will acquire a velocity. So it will keep continue in its motion on its path, like on the arc, till the time the velocity becomes zero. But when it reaches here and velocity is zero, you see your, suppose theta 1. So t cos theta 1 now has become, or t sin theta 1. Sorry, you can write this better. T sin theta 1 in the horizontal direction will be lesser than ma naught. So because of this pseudo force, it will go back again in this direction. So basically, the pendulum will start oscillating around its equilibrium position. It will go up, come back like this, then again go, come back like this. So about this axis, about the axis of equilibrium, if you say that this is the axis of equilibrium and the angle for that you have already got here. So it will oscillate about this axis. So this is the whole concept. I hope you understood it. In case any doubt, please do write in the comment box. We'll clarify your doubt. Thank you.